tell me one thing. For a connected graph, the complement, can I say it will definitely be connected? Like if you have a connected graph, let's assume you have a connected graph, then can I say complement will definitely be disconnected? Can I say complement will definitely be disconnected? Can I guarantee this? Can I guarantee this? Tell me that connected graph complement will be disconnected. The answer will be no. Because for example, you can consider this graph A, B, C, D. This graph is connected and its complement that is also connected. Its complement is also connected. You can notice its complement is also connected. So this is also connected. So this is also connected. This is also connected. So I can say that a connected graph complement need not be disconnected. And can I say connected graph complement is connected? Can I say connected graph complement? Like if I give you this connected graph, for example, A, B, C, let me give you this connected graph. Then what is G complement? G complement will be disconnected. G complement will be disconnected. And this is your connected graph. So what can I say finally? I can say for connected graph, for a connected graph, the complement will be either connected or disconnected. Yes, correct. And what about disconnected graph? See, this is a disconnected graph, so its complement will be this. So for disconnected graph, the complement can be connected. Yes or no? For a disconnected graph, the complement will be this. For a disconnected graph, the complement can be connected. The interesting question is, can you give me a disconnected graph whose complement is disconnected? Give a disconnected graph. Can you create a disconnected graph? Please try. Can you give a disconnected graph whose complement is disconnected? Whose complement is also disconnected? Who is also disconnected? So can you try? Can you try? A single vertex graph is connected. Single vertex graph is connected or disconnected? Please tell me. Single vertex graph. This K1 means single vertex graph. This is connected because it has only one component. This is connected. This is not disconnected. This has only one component. So this is actually connected. This is not disconnected. Don't call it disconnected. This is not disconnected. This is not a disconnected graph. This is a connected graph because only one component you have, only single component you have. This is the definition of connected. And what about, this is my question. Can you give me a disconnected graph whose complement is also disconnected? Anyone want to try? Anyone has some ideas? Like, do you want to try or not? So anyway, the answer is whatever you do, it is not possible. The answer is not possible. The answer is not possible. So if you have a disconnected graph, if your graph is disconnected, then its complement will also be, then its complement will definitely be connected. If you have a disconnected graph, its complement will definitely be connected. But how to prove it? So this is what we want to prove. The complement of disconnected graph is necessarily connected. First of all, you tell me the first statement. Is it true? Is it true that complement of connected graph is necessarily disconnected? Complement of connected graph is necessarily disconnected. This statement is false. We have already seen. This is a connected graph whose complement is not disconnected. So for a connected graph, the complement can be connected or disconnected. Now we have to prove that complement of disconnected graph is necessarily connected. This is what we have to prove. And the proof is actually very simple. Okay, so this is what we have to prove. You have to prove that if G is disconnected, then G complement is connected. This is what we have to prove. This is okay. So now let's see. Preeti is saying, can we say that a complete graph, the complement is disconnected? Yes. If you have, what is the complement of complete graph? Can anyone tell me what is the complement of complete graph? That is the edgeless graph, that is the null graph, correct or not? So if you have k3 complete graph on 3 vertices, then the complement will be null graph on 3 vertices. And of course you can check that the complement of complete graph will be disconnected if and only if n is greater than equal to 2. If you have k1, the complement of k1 will be k1. Yes or no? The complement of k1 will be k1. Now let's prove this. If G is disconnected, this is given to you. If G is disconnected, this is given. Then G bar is connected. This is what I want to prove. I want to prove that G bar is connected. And what should I do? What is your suggestion? G bar is connected. What should I do to prove that G bar is connected? The proof is like this. What you do? Let me take 2 vertices in G bar. Let me take any 2 vertices in G bar. Okay. If it is connected, then what should happen? If it is connected, then what should happen? If I take 2 vertices in G bar, if I want to prove G bar is connected, what should happen? There should be a path exist. See, you take 2 vertices, whatever 2 vertices you take. So just take 2 vertices in G bar. Now, basically we have to prove. What we have to prove? We have to prove that there is a path from A to B. This is what we have to prove. Correct? Agree? Very simple. This is what you have to prove. So you are taking 2 vertices in G bar and you have to prove that there exists a path between these two. Now for these 2 vertices in G, what are the 2 situations? For these 2 vertices in G, what are the situations? See, there is a case 1. What is the case 1? That A, B are adjacent. That A, B are adjacent in G. Yes or no? This is the possibility that they are not adjacent in G. Let's assume only these 2 cases are possible. Case 1, A, B are not adjacent in G. Correct? Either this possibility, or what is another possibility? Either A, B are adjacent or A, B are not adjacent. So either A, B are adjacent or A, B are not adjacent in G. Okay, very simple. Only 2 cases are possible. So what I'm doing, this is my graph G and this is my graph G bar. Tell me, vertex set is same? Yes or no? Vertex set is same, right? For G and G bar, vertex set is always same. So you know that if G is V, E, then G bar is V, E bar. Vertex set will be same. You know that vertex set will be same. So this vertex set is going to be the same. This always will be the same. So that is the reason I'm saying that I'm taking 2 vertices and I'm saying that this is what we have to prove. We have to prove that there is a path. Now for these 2 vertices in G, what will happen? In G, what will happen? In G. So either they will be adjacent or they will not be adjacent. If they are not adjacent in G, then can I say they will be adjacent in G bar? If they are not adjacent in G, means there is no edge between them in G, then it means what? It means A, B are adjacent in G bar. Adjacent in G bar. So there is a path. So there is a path. So I can say that so there is a path between A, B. So there is a path between A, B. So this case is done. Yes or no? This case is over. We have done this case. Now what? Now what? Now this case is remaining. A, G are adjacent in G. If A, G are adjacent in G, but G is disconnected, right? You agree that G is disconnected. It is given to you that G is disconnected. And A, B are adjacent. It means A, B are in one component. It means they are in one component, like C1. They are in one component. Yes or no? Because they are adjacent, right? They are adjacent. So they are in one component. Agree? Yes or no? In G, they are in one component. In G. So in G, from G point of view, they are in one component. And G is disconnected. This G is disconnected. So in G, you have another component also. At least 2 components you have. In G, you have at least two component. So you have at least two component in G. So there is some vertex here. Tell me one thing. Can I say they are adjacent? Do we have are they adjacent? A comma Z? No, because they are different components. C1 and C2, they are different components. So they are not adjacent. They are not adjacent because this C1 and C2, they are different components. So what will happen in G bar? Now tell me what will happen in G bar. In G bar, what will happen? If they are not adjacent, then they will be adjacent in G bar, and they will be adjacent like this. Yes or no? So finally, what it means? What it means? It means there is a path between A comma B. It means there is a path between A comma B. It means there is a path between A comma B. And this is what we wanted to prove. So whatever case happens, case 1 or case 2, whatever happens, there is a path between A comma B. Yes or no? Did you understand the proof? See, okay, just understand, please understand. See, G is a disconnected graph. This is given to you. What it means, if graph is disconnected, what it means? Tell me. Disconnected graph, what it means? First, you tell me disconnected graph means what? Disconnected graph implies at least two components. You have at least two components. There are at least two components in G. Okay, you have a disconnected graph G, then it means there are at least two components in G. In G, you must have at least two components, C1 and C2. Okay, there must be at least two components, at least. There can be more. You must have at least two. Okay, next, what you have to understand. So G is disconnected, this is given to you. We have to prove that G bar is connected. So what we have to prove? G bar is connected, this is what we have to prove. In G bar, if you take two vertices, then to prove that this is connected, what we have to prove? We have to prove that there is a path between A comma B. So actually, this is what we have to prove, that there is a path between A comma B, whatever two vertices you take in G bar, because this is what we have to prove, that G bar is connected. To prove this, we have to prove that whatever two vertices you take in G bar, there should be a path. Is this clear? This is what we have to prove. So this is what we have to prove. Okay. Now tell me one thing. Two cases are possible for these two vertices because vertex set is same. G and G bar, they have same vertex set. Their vertex set is same. So what you can do, for these two vertices, you can check what will happen in G. For these two vertices, two things can happen. Either they are not adjacent or they are adjacent. Yes or no? If they are not adjacent in G, then in G bar they will be adjacent, because in G there is no edge between them. In G basically there is no edge between them. So in G bar there will be edge between them. So I can say this is your case 1. What is case 2? Case 2 is saying that A comma B are adjacent. It means they are in the same component. Yes or no? It means they are in the same component. So this A comma B, you can notice they are in the same component. And this graph G is disconnected. It means there is one more component, at least one more component you have. At least one more component you have. Okay. Now in this component, you take this vertex Z. Now this is happening in G. Remember, this whole thing is happening in G. So what will happen in G bar? This whole thing is happening in G. Then what will happen in G bar? Tell me. In G bar, because remember, in G there is no edge. In G there is no edge between A comma Z. So in G bar there will be edge between A comma Z. And in G there is no edge between B comma Z. So in G bar there will be edge between B comma Z. So this is your path. This is your path from A to B. So we have a path from A to B. So whatever case you have, case 1 or case 2, whatever case you have, G bar will have, in G bar, for every two vertices we have path. So whatever two vertices you take in G bar, you have path. You have path. So whatever two vertices you take, they have path. So I can say G bar is connected. Is this clear to everyone? This proof, did you understand? This is a very simple proof. Only definitions we are using. Can you notice? Only definitions we are using. So if you have disconnected graph, then its complement is definitely connected. Remember, disconnected graph complement is definitely connected. But a connected, if you have a connected graph, its complement can be connected or disconnected. Its complement can be connected or its complement can be disconnected. So this is what we have. How many understood this proof? This very simple, cute proof, very cute, right? Like, I hope you are finding this very simple. Only definitions we are using, nothing else. Just using the definitions. We are using the definition of connected. We are using the definition of disconnected. We are using the definition of complement. So these things we are using. Only definitions we are using. The definition of connected, definition of disconnected, definition of complement. These three definitions we are using. So this is a simple proof. So prove that complement of a disconnected graph is connected. This we have done. Consider this question. Which of them is true or false? The complement of simple disconnected graph must be connected. The complement of simple connected graph must be disconnected. Which of them is true or false? So let me tell you. First of all, what is complement? Do you know? What is complement of a simple graph? What is that? Complement of a simple graph. That is defined with respect to which graph? Complement of a simple graph that is defined with respect to which graph? That is defined with respect to complete graph. Yes, very good. So what is the complement of a graph? First, let's see that. So if you have let's assume you have a graph G with n vertices. Okay. If you have a graph G with n vertices, then what is complement of this graph? G complement. So let's assume you have a graph G, V comma E, where number of vertices is equal to n. So what will be G complement? G complement will be set of vertices will be same. Remember, set of vertices will be same. Set of vertices will not change. So set of vertices will be same. Now the set of edges that will complement. Set of edges will be set of edges. I can say in Kn, set of edges in Kn minus set of edges in G. Set of edges in G. Correct? So this is the idea of complement of a graph. What is the complement of a graph? Let's take example. With the example, this concept will become clear. So let's assume this is your graph. A, B, C, D. Let's assume this is the graph. Now what will be the complement of this graph? You can clearly see that number of vertices is equal to 4 for this graph. Number of vertices is 4. So what will be the complement of this graph? Vertices will be same. Vertices will be same. Vertices will be exactly same. So don't change the vertices. Now what will happen? Basically the edges will be those edges which are not in G. Those edges which are not in G. Okay. So you can notice these edges are not in G. So I can say these edges, those edges which are not in G. So this will be the graph. This will be G complement. Okay, very simple. This is the concept of complement of a graph. For example, if I give you a graph A, B, C, D, if I give you this graph, then what will be G complement? Again here you have 4 vertices. So number of vertices will be same. The set of vertices will be same. Vertex set will not change. So set of vertices will not change. Now this is your set of vertices. Now here in the G days in G complement, the edges will be those which are not in G. So let's assume this is your G. Now the edges will be those which are not in G. So which edges are not in G? In G complement we have those edges which are not in G. So you can notice this edge is not in G, this edge is not in G, this edge is not in G. So this will be your G complement. Okay, so quite simple. Now, so this is the concept of G complement. Basically I can say G complement is basically that is Kn minus G. Okay, I can say that is Kn minus G. Vertices will be same in terms of edges. In terms of edges. In terms of edges. In terms of edges, this will happen. But remember, vertices will be same. G comma G complement, they have the same vertices. Okay, so this is the simple idea. Now, one thing you can clearly see, the statement is saying that the complement of simple connected graph must be disconnected. Simple connected graph must be disconnected. This statement, the complement of connected graph must be disconnected. This statement is false. Why this statement is false? Because you cannot, this is connected. Can you notice this is connected? This is also connected and this is also connected. So this statement is false, right? Is this clear? So this statement is false, correct? Yes or no? So definitely I can say this statement is false. So this statement is false, because you can clearly see that if I give you this graph, like consider this graph A, B, C, D. If I consider this graph, okay, this is your graph G, then your G complement will be what? G complement will be set of vertices will be same. Don't change the set of vertices. Set of vertices will be same. Those edges which are not in G. Okay, so you can clearly see this is also connected. This is also connected, and this is also connected. So G dash is also connected. G complement is also connected. So this statement is false. What about the first statement? Tell me. What about the first statement? The first statement, that is true. First statement is true. So if you have a disconnected graph, the complement will definitely be connected. So basically what is happening here, very simple, that if you have a connected graph, the complement may be connected or disconnected. The complement may be connected or disconnected. Okay, the complement may be connected or disconnected. For example, you can notice here the complement may be connected or disconnected. For example, you can consider this graph G. Consider this graph G. Okay, now this graph is connected. This graph is connected. But if you find G complement, number of vertices, this vertex set will be same. Vertex set will be same. Those edges which are not in G. So you can clearly see this is disconnected. So what I am saying that for the connected graph, the complement will be connected or disconnected. Okay. But for disconnected graph, if you have a disconnected graph, for disconnected graph, the complement will definitely be connected. Can we prove it? Can we prove it? This is very easy to prove. Okay, this is very easy to prove. If you have a connected graph, let me just prove it. Basically, this is quite easy and this is more intuitive. Can you take your copy pen? Can you do it parallel? Okay, I am doing it. You can also do it in parallel. So the complement of disconnected graph is connected. What is the proof? The proof is quite easy. So let's take a disconnected graph. Okay, take G as a disconnected. So this G is a disconnected graph. Now this G is a disconnected graph. If this is a disconnected graph, what is the number of components? Tell me, if this is a disconnected graph, what is the number of components? This is a disconnected graph. What is the number of components? So here definitely, because this is disconnected graph, so number of components will be greater than equal to 2. Number of components will be greater than equal to 2. Okay, that will be the number of components. These many components will be there. So number of components, that will be greater than equal to 2. Okay, now you tell me. So basically in this graph G, there are 2 components. Definitely at least 2 components are there. Definitely. Now in G complement, let's focus on G complement. This is my claim. What is my claim? My claim is that G complement is connected. Okay, what should I do if I want to prove G complement is connected? What should I prove? What should I show? I should show that between every 2 vertices there is path. Between every 2 vertices, correct? Between every 2 vertices there is path. Between every 2 vertices there is path. Yes or no? I should prove this. If I want to prove that G complement is connected, then I should prove that between every 2 elements, between every 2 vertices there is path. Tell me one more thing. Do they have the same vertex set? G comma G complement. Do they have same vertex set? G comma G complement, they have the same vertex set, right? So G comma G complement, they have the vertex set is same vertex set. So the vertex set will be same for both of them. Same vertex set. Now I want to prove, this is what I want to prove. I want to prove that between every 2 vertices there is a path. So take 2 vertices. Okay, so take 2 vertices. Now what you do? You take any 2 random vertices. Take any 2 random vertices A comma B. Then what are the 2 possibilities? What are the 2 possibilities for these 2 vertices in G? For these 2 vertices, what are the 2 possibilities in G? If you take 2 vertices, okay, in G complement, then they definitely also belong to G also. they also belong to G, because G and G complement, they have the same vertex set. The vertex set is same, correct? So definitely this, they also belong to G. Now, so if you take two vertices in G complement, then there are two possibilities. So basically in G complement, I am taking two vertices. I am taking two vertices in G complement. Those are A comma B. Now, for these two vertices, there are two possibilities. What are those two possibilities? See, there is two possibilities. Either A comma B are in different components. Either they are in different components, either they are in different components, or they are in same components in G, or they are in same components in G, correct? Are in same component in G. Agree? Do you agree only these two possibilities can be there? Okay, for vertex A comma B, there are only two possibilities. Only two possibilities. Either they are in different components or they are in same components. Okay, there are only two possibilities. In G, in the graph G, they are either in different components or they are in same components. Your graph G is disconnected. So your graph G is disconnected, so number of components is greater than equal to 2. Now, if you take any two vertices, then there are two possibilities. Either they are in different components in G or they are in same component in G. Now, in this case, what will happen in G complement? In this case, what will happen in G complement? Tell me. In G complement, what will happen? In G complement, there will be edge between them. Yes or no? In G complement, there will be edge between them. Definitely, there will be edge between them. Correct? Yes or no? In G complement, there will be edge between them. Because there is a edge, so there is a path. So I can say there is a path. Because there is edge, so there is a path. So in this case, I can say that there is a path between A comma B. Yes or no? So in this case, I can say there is path between A comma B. In this case, I can say. In this case, I can say that there is path between A comma B in G complement. Is this clear? Tell me. So far, is this clear? That in this case, there are two cases possible. Case 1, case 2, there are two cases possible. And in this case 1, what we have done, we have proven that there is path between A comma B in G complement. Okay, in G complement, there is path between A comma B. This is your case 1. What is case 2? What is case 2? Now, case 2 is basically that A comma B are same component in G. So in G, they are in same component. This is your graph G. In this graph G, this A comma B, they are in same component. So there is some other component also. Yes or no? Definitely there is some other component also, because number of components is equal to greater than equal to 2. In graph G, number of components is greater than equal to 2. So there is different component also. There are at least two components. Yes or no? See, very step by step I am going. Everything step by step I am telling you. So you can notice in G, in the graph G, you can notice these are in same component. These are in same component. These are in same component. Now, what I am saying that, then definitely there is another component. There is another component. So in G complement, what will happen? So in G complement, what will happen? Tell me. In G complement, what will happen? Definitely there will be edge between these two, and definitely there will be edge between these two. Yes or no? Correct? Agree? Now again you can notice, so there is a path. Again you can notice there is a path between A comma B. So in this case 2 also there is a path between A comma B. In this case 2, what we have done? In this case 2 also there is path between A comma B. So whatever case you take, there will be path between A comma B. So two vertices you take, basically two vertices you take, whatever case happens, there will be path between A comma B. So what we have done in G complement, you take any two vertices. In G complement, you take any two vertices. What we have done, we have proven that in G complement there will be path between them. Whatever two vertices you take, we have proven that in G complement there exists a path between these. Tell me, is this point clear or not? Let me know. This proof, is this clear to everyone? See, step by step, everything I told you, okay, in a sequence. Please tell me, is this proof clear or not? Anyone has any doubt in this proof? One more suggestion I want to give you. This is a suggestion for basically for whole your life. So whenever you see any proof, always work it out. As I told you that work it out, take your copy pen, don't watch it like a movie, because these proof, if you prove something, then you will feel confident. Whenever you prove something, you will feel some satisfaction. Some satisfaction you will feel that, okay, you have proven it. You have proven this statement. Okay, the proof you have seen. So that satisfaction you will feel. And remember, whenever you are proving something, then always take your copy pen and do it yourself. Okay. So this is a simple proof if you do it yourself. Step by step, if you do one by one in a sequence, okay, one after one, if you do this, then this is a very simple proof and we have done it. So what we have proven? Tell me what we have proven. So we have proven that if you have a disconnected graph, so this is what we have proven. If you have a disconnected graph, then the complement will be connected. Then the complement will be connected. So this is the first thing we have proven. And the second thing, if you have a connected graph, then the complement may or may not be disconnected. So the complement may be connected or the complement may be disconnected. The complement may be connected or complement may be disconnected. So these two things we have seen. From these two things, can I say that G or G complement, at least one of them will be connected? Tell me, can I say this? So can I say for every simple graph, for every simple graph G, I can say that for every simple graph G, whatever you simple graph G you take, okay, either G or G complement is always connected, Either G or G complement is definitely connected. At least one of them is definitely connected. So I can say basically at least I can say that at least one of both of them also can be connected. At least one of G comma G complement must be connected. Or I can say is always connected. I can say at least one of G comma G complement is definitely connected. Is this clear? Let me know. It cannot happen that both of them are disconnected. It cannot happen both. It cannot happen. Remember, it cannot happen that G comma G complement are both disconnected. It cannot happen. At least one of them will be connected. So this is quite simple. Yes or no? So this is a simple idea and the proof we have seen. So what we have done in this question, what we have done? So this statement is true. The complement of disconnected graph must be connected. The complement of connected graph may or may not be connected. Okay, so I can say that what we have done, this proof we have done, right? Yes or no? This proof we have done for any graph, either G or G dash is connected. Also, if G is disconnected, then G dash is connected. Okay, so this is the proof. So all these three questions we have done. Okay, this is the idea.